This is Jack Jackson. In this video, we're going to continue our going over the review exercises from Unit 1 on Descriptive Statistics. In our last video, we worked through the first 5 exercises and we'll work through 5 more on this one. As before, you will be shown a slide with questions and be asked to pause, work them on your own, and then come back and check them as I go over the next slide. Exercise 5, on the previous video, we included some statistics and parameters for which we did some definitions and formulas like that. And what we're going to do here with review exercise 6 is a similar thing. So write down the symbols, formulas, and definitions for the following parameters and statistics. A, mid-range. B, median. C, mode. D, quartiles. E, interquartile range. F, mean absolute deviation. And G, outlier. Press pause now. So the mid-range is 1/2 of the minimum plus the maximum. So it's a value that's exactly the same distance from the minimum and the maximum. So it's a measure of central tendency. The median is a little more complicated to explain, but what you do is you rank the data in increasing order and find the value in the middle. So there's sort of 2 cases there. If n is odd, then this will be the data value with rank 1/2 of n plus 1. If n is even, there will be 2 values tied for the middle ranks at 1/2 n and 1/2 n plus 1. In this case, we add these 2 data values and divide by 2 to find the median. So approximately 1/2 of the data is below the median. The mode is the single most often occurring data value. And in my class, if there's a tie, a 2-way tie, we say it's bimodal and we count on both as being in the mode. But if there's a 3-way or more than 3-way tie, we say there is not a mode. So the mode may not exist. The quartiles divide the data into 4. So there are 5 of them: Q0, Q1, Q2, Q3, Q4. The outer ones are usually not called Q0 and Q4. They're referred to as their normal names. Q0 is the minimum, Q4 is the maximum. And likewise, Q2 is the median. And usually it's referred to as the median rather than just Q2, but it is Q2 as well. Q lower, or Q1, is the median of the lower half of the data, and Q3 is the median of the upper half. Don't count the median in either half. That's the TI-84 method of finding the quartiles, which is the primary method we're going to be using in my class. There are other methods of doing the quartiles. So when you're reporting data with quartiles, you should be sure to say which method you're using. The interquartile range, or IQR for short, is Q3 minus Q1. Of course, it's going to depend on which versions of Q1 and Q3 you use. The mean absolute deviation, or MAD for short, is averaging the absolute deviations. I mean, it's exactly what it says, the mean of the absolute deviations from the mean. So what you do is you take your data value, x sub k, you subtract the mean. If it's a sample, that will be x bar. Find those deviations, do the absolute value of those, and then just average them. Add them up and divide by how many you have. Just do the same thing for a population. It's the same formula. Instead of x bar, the population mean is mu, and of course capital N for the population size. And an outlier is an extreme value that's unusually high or unusually low. And the primary rule that's used for that, it's any value which is less than Q1 minus 1.5 times the interquartile range, or greater than Q3 plus 1.5 times the interquartile range. Those are generally considered outliers. There are a few other methods of computing outliers, but that's the primary one that's normally used. Okay, next we're going to do review exercise 7. List the 3 main portions of a probability and statistics course and explain what they are. Press pause now. Well, the 3 main branches of this course are descriptive statistics, probability, and inferential statistics. Descriptive statistics uses numerical and graphical methods to make sense of data, allowing us to effectively find and communicate important information from the data set in order to reach conclusions and make good decisions. Descriptive statistics will be covered, or has been covered, in this first playlist and in Unit 1 in my course, and that's what these review exercises are over. Probability is the second part of the course. It's used to draw conclusions about the likelihood that an arbitrary sample will have certain characteristics given information about a known population that it's drawn from by assigning a numerical value between 0 and 1 inclusive to this event measuring the degree of uncertainty. So it gives us a way to quantify uncertainty. And notice that it works from some known situation about a population and assigns a likelihood to a particular event or a subset or a sample. Inferential statistics in that sense is backwards from probability. It is used to draw conclusions about a population given information about a representative sample and uses this information in good decision making. So all three parts are very important, but where we're really headed in this course is making sure that we can do inferential statistics, which requires that we first be able to do descriptive statistics and probability. Review exercise 8. Identify characteristics of a correctly constructed bar graph so that it does not distort or misrepresent data. Press pause now. Well, for a bar graph, you should have several characteristics. Of course, it has bars, and those bars should be two-dimensional rectangles. They could be vertical or horizontal. Usually, I usually like to use vertical bars, but horizontal are acceptable as well. But the bottom of all bars must be at 0, and there are no breaks in the axes. Otherwise, you distort what is going on with the bar. The widths of all the bars should be the same, and the height of the bar is the value of the data. So you can read the value off of the height of the bar. Areas of the bars are also proportional to the values of the data because they all have the same widths. Axes should be clearly labeled, including appropriate units. They should have a title indicating the main topics of the graph, and the source of the data should be identified if it's not obvious from the placement of the graph in your presentation. So you can see some people will abuse this sometimes, so be careful that you don't see things like 3D graphs on bar graphs distort data, bars that don't start at 0 or that have breaks in the axis or that the widths change. All of those are ways to misrepresent data. You always want to make sure that you're representing data accurately in a graph. So there's no point in distorting the data. Exercise 9. What is meant when we say that a person's IQ is at the 92nd percentile? Press pause now. This means that their intelligence quotient, IQ, as measured by some appropriate test, is higher than 92% of the IQs measured by this same test. So on this particular scale, this person measured better than 92% of the people taking the test. It does not, for example, mean that they got 92% of the questions correct. Exercise 10. Construct a dot plot and a modified box plot for the following data set. Construct this by hand using graph paper, and then also construct at least the modified box plot using your calculator. Okay, here's the data set. 14, 6, 16, 19, 17, 18, 26, 19, 22, 20, 19, 24, 18, 19, 18, 21, 19, 17, 20, and 19. Press pause now. So a dot plot you can see here in this graph here in the lower left hand corner starts with a usually a horizontal number line, In this particular one, I have the number line going from, looks like about 4 to about 30, which is more than enough. It turns out my lowest value, the minimum was 6 and the maximum was 26, so it needed to go at least from 6 to 26, or maybe just a bit beyond that. So every time we come to a data value, such as say 14, we find 14 on the number line and we put a dot right there above it. The next data value is 6, we find 6 on the number line, put a dot above that. Then we go to 16 for a dot, 19 is a dot there, 17 here, and so forth. Eventually you'll get more than one of something. So for example, here's a 19 in the data list and there's another 19 here. So above the second dot, instead of being on top of the first one, is above it on the same vertical line. And so you just keep doing this until you get to the end of the data set, and we have one dot. These darker dots here above the line are each one dot for each data point. Now, if we put this data in order, we can read it off of the dot plot now in order. If we want a 6, then a 14, and a 16, and 17, and 17, 18, 18, 18. 3 of those. Looks like we got 6 19s and so forth. And I've written the data in order here like this. I've got it color-coded a little bit, if you can see that shows you this. So we kind of breaking it into 4 groups of 5. 6, 14, 16, 17, 17 is the bottom fourth. Then 18, 18, 18, 19, 19 is the next one. The other 4 19s and a 20 is the next fourth, and the highest fourth is 20, 21, 22, 24, and 26. So if you look, there's an even number of data values there. If we just, first of all, we might just count them. And I believe that is 20 data points. So if you break that in half, that's the lower half of 10 and the upper half of 10. So the lower half is the red and green ones here, and the upper half is the, I guess that's some kind of maybe a tan color and a purple here. And that's the upper half. So the lower half and the upper half, there's sort of a tie for which one's in the middle in this ranked list, and it's a tie for these two 19s. So you add those two up and divide by 2, which of course still gives you 19. So that's the median. The median is right there in the middle. Now, had there been an odd number here, the one in the middle would have been the median, and it would have been the same number from the top and bottom. Same rank. Okay, so 19 is the median. That's also known as Q2. Q1 is the minimum. Q0 is the minimum, which is 6. The maximum, or Q4, is 26. So now we just need to find the other quartiles. Now, if we're going to use the TI-84 method, which is what we're going to do in this class, you take the lower half, including the median, if it's there, and we look at this lower half, cut it in half again, and that's between, there's 10 in the lower half, so the 5th and 6th one from the bottom, 17 and 18, must be averaged, add up and divide by 2 to get the Q1. That's 17 and a half. Likewise, we take the upper 10, find the 2 in the middle, which is 20 and 20, average those to get 20 for Q3. So we have found the 5-number summary, or quartiles. Minimum is 6, Q1 is 17.5, the median is 19, Q3 is 20, and the maximum is 26. Now, the way to illustrate this with a box plot is this. First of all, let's start with the median. That's 19, which is right here on the number line. We put a vertical line, and this could be done above or below this number line. Since I have the dot plot above it, I'm going to put the box plot below. And so I'll draw a little vertical line at 19. Similarly, we draw one at the Q1 and Q3 at 17.5 and 20. And so we draw vertical lines, and then we make a little rectangle out of that with a vertical line in the middle, and that's our box. Now, if it was an unmodified box plot, you would just draw a whisker out to the maximum of 26 and stop there, and it would go all the way out to there. And the whisker would go from the Q1, 17.5, all the way down to the minimum of 6. But with a modified box plot, it also identifies outliers. So to do that, we need to find first of all, we need to find our interquartile range. Well, that's just the width of this box right here. The box in the middle. So it's the distance from Q1 to Q3. That's Q3 minus Q1, or 20 minus 17.5 is 2.5. So this box right here is 2.5 long. That's called the interquartile range. Now if you multiply that by 1.5, you get 3.75. Okay? So what you do is you take 3.75 and add it to 20 to the Q3. Okay, so that would be 23.75. So anything that's above 23.75 is an outlier. So in our case, that was the 24 and the 26. So those two are outliers. We put some kind of symbol there. And then the next one that is at or below the 23.75, namely this one is the 22, is where we draw our whisker to. Similarly, on the low side, we take the Q1 minus 1.5 times the interquartile range. So remember, once again, the interquartile range was 2.5. 1.5 times that was 3.75. So the lower fence is Q1 minus 1.5 times IQR. So that's 17.5 minus 3.75 is 13.75. So anything below 13.75 is considered an outlier. Well, the only one that is this one at 6, which is an outlier. So 6 is an outlier. But this 14 barely makes it above the fence, so it's okay. It's not an outlier. So where do you draw the whisker down to? To the lowest one that's not an outlier, which in this case is the 14. So now if you notice, our whiskers don't go from the minimum up to Q3 or from up to Q1 and from Q3 up to the maximum. They go from the lowest one that's not an outlier, in this case 14, up to the Q1 of 17.5. And the top whisker goes from Q3 at 20 up to 22, which is the highest one that's not an outlier. And the outliers, these two on the upper end and the one on the lower end, are marked with some kind of mark, in this case a dot. Okay, if we want to do this on our calculator, you just do this. A TI-84 doesn't do a dot plot, but it does do a box and whiskers plot. So actually, let me do this here on a calculator. Let's start with the TI-84. We can go to Stat, Edit. First thing you want to do is go up here and clear this out. Clear list 1. I'm going to just clear list 2 just to get it out of the way. So you put your cursor on the label, hit clear, and enter. And you type your data in. You can just type it in the order that it is given to you. So here we go. 14, enter, 6, enter, 16, enter, and so forth. Okay, so hopefully I'm getting all these in here correctly. I think I missed one. All right, I'm going to find it. Hang on just a minute. Okay, I found it. Okay, now we've got it in there, all our data. Now, we want to go to a plot. So we go to second, y equals will be stat plot. Click on that, turn the plot on. We go down here to these right here. If you go to this one right here, it's a box and whiskers plot that's not modified. And if you click on that one, it'll be modified to include outliers, which is what we usually prefer. Our data is in list 1, L1, frequency 1, and that's what I usually use for a mark. That looks good. Okay, we can quit that and say zoom stat. Actually, before I do that, I'm going to go here and just in case I've got anything else I don't want it to graph, so just clear that out or turn them off. Now do zoom stat, zoom 9, I think. Yep, zoom 9. And it graphs it. Now if you do a trace here, you can see that there's a minimum at 6. 14 is the next part where that goes to. It's where the lowest one that's not an outlier. Then you got Q1, there's the median, Q3. The next one that's not an outlier is 22, and then another outlier at 24, and an outlier of maximum at 26. You can just try to go around like that. Unfortunately, it doesn't put the numerical scale on the number line, which it should, but you could go to the window settings and see what that is. So that's a box and whiskers plot on that calculator. On the Inspire, we want to add a spreadsheet first. And I don't have a particular name for this. I'm just going to call it data. So we might name this something. Whoops. Okay. Here's where we want to put that in. I need to clear this list out though. So a way we can do to clear that is get on the equals, and then from the menu we can go to data and clear data, and it should, let's clear that. Let's try it again. Menu, data, well, okay, let's try this again. Menu, data, there we go, number 4, clear data. Okay, so that clears it off. I should just type the title up here on the top one. There we go, that just gives it a name. And now we can type our data in here. 14, 6, 16, etc. So I've now finished typing all these in. So next what we do is we go back to the home and we enter a data sheet like this. Now it has a bunch of dots here for data, and they're just kind of randomly in there, right? But we can make them into a dot plot like that, which we just did. Another thing we could have done is just gone under here and clicked on dot plot. Now it's in a dot plot. I can now right click on that though and turn that into a box plot like that. Okay, and so you can see the screenshots here on the slide that's showing you that as well. So we can get the calculators to calculate these values and to tell us actually show us these videos. I mean these graphics. And this one, I believe, if I put my cursor over that, it will actually just it'll tell me my same information like the trace did on the other one. I just have to do it by moving the cursor around here using the touchpad or the little arrow keys. Okay, I think that's going to take care of us through exercise 10. Come back to the next video for the next set of 5 review exercises.